So I'll blindly put a minus 2 is equal to, careful guys, you will frame an equation, it's like math. You'll have to equate to something. Equate always to the power. Okay, equate always to the power or equate always to the valency. Whatever you guys are comfortable with. In this case, the power is or the valency is minus 2 is equal to minus 2. Okay, will there be a number always on top of it? No. If there is no number, you'll put a 0. But in this case, since I can see a number, you'll put minus 2. Fine. So it'll be like 2x. Solve for x right now. So minus 14 is equal to minus 2. The minus 14 comes and becomes plus 14. So 2x is equal to minus 2 plus 14. 2x is equal to 12. X is equal to 6. To be more precise, plus 6. You know what this means? It means that in Cr2O7, the charge on chromium alone is plus 6. That's the meaning of it. Okay? The charge on chromium alone is plus 6. I'll give you more examples. Let's talk about nickel. Fine. This is also a very important question. That's why nickel, they'll be like, find the oxidation number of NiCl4 2 minus. Okay, NiCl4 2 minus. Again, I'm supposed to find for what? Nickel. How do I know? They have told me. In this question, nickel, how many are there in number? 1 nickel. So put X. Put plus. Why? Nickel combined with chlorine. Getting it? Now, how many chlorines are there? You got to ask yourself the question first. 4. Open brackets. But the good thing here is, for chlorine, we know a valency already based on valency chart. What is it? Cl 1 minus. So here, you'll go back, you'll put minus 1 is equal to, look at the top here. There's some power here also, or valency here also, is equal to minus 2. That's it. So now, find the value of x. Simple. X plus into minus gives you minus 4 is equal to minus 2. Now, find the value of x. X is equal to minus 2 plus 4. X is equal to plus 2. Now, what does this mean? This means that the charge on nickel in NiCl4 2 minus is equal to plus 2. If you ask me, sir, will nickel have the same answer or the same valency every time? No. It can keep on changing. It has the right to change. You cannot question it. Okay? It can keep on changing. Remember this. Now, this was about NiCl4 2 minus. I'll give another example also. With the same nickel, I'll give. This time, let's try NH3. Okay, one second, wait. Let's start nickel. We'll do cobalt. CO NH3 CONH3 2 minus. Okay, randomly will I think 3 minus will take 3 minus it is. Okay, this is the compound. 3 minus or plus. So okay, we'll do it plus this time. Fine. Now focus. Can it be plus on the valency? It can be whatever. But the thing here is, I'm going to teach you a rule here. CO meaning cobalt. I'm supposed to find for cobalt. Consider that to be X. Done. Plus. Okay, 1 second. NH3 is 4 in number. Okay, or 6 in number. We'll take 6 in number. Okay. So totally how many NH is there? 6 in number. So I'll put 6 there. Careful. The problem here is we do not know the valency of NH3. That's a big problem. Don't you think NH3 is a compound? Always remember, the charge on compounds will be 0. Okay? The charge on compounds will be 0. We might argue say ammonia is a compound, ammonium is an ion. That's correct. That's correct. But what is given to me? NH3 or NH4 1 plus? NH3 is given to me. So if it is NH3, the answer is 0. If it is NH4 1 plus, then you'll think about something else. You'll always think based on the question itself. Now the question said NH3, so stick on to NH3 itself. NH4 1 plus is if it is required, we'll talk about that later. Now in this case, NH3 was given. It's a compound. Compound meaning 0. Put a 0 next to 6 is equal to, what is the charge? The total charge is plus 3. Put it as plus 3. Fine. Find the value of x. X plus 0 is equal to 3. X is equal to plus 3. Now what does this mean? It means that the charge of cobalt in this compound called as whatever is equal to plus 3. That's the meaning of it. We'll do one more. We'll do NiCN4 2 minus. Okay. Now, simple. I'm supposed to find for nickel. Okay. X. How many number? One in number. Only one nickel is there. So put X plus Y plus combining. 4. Cn meaning cyanide. Okay, remember Cn is never a compound. It looks like a compound. It is very deceiving. Okay, but understand Cn is never a compound. Cn, the charge is always like chlorine, chloride, cyanide. Can you see the difference? Almost they sound the same also. So chloride, cyanide. So here 4 into minus 1. Why? Chloride was minus 1. Cyanide will also be 1 minus or minus 1 is equal to, I hope you guys realize as to how it is 4 in number because there are 4 cyanides, is equal to minus 2. Okay, so x plus into minus gives you minus 4 is equal to minus 2. X minus 4 comes inside, becomes plus 2. So in this compound, the oxidation number of Ni is equal to plus 2. Fine. Will they ask exactly this? The answer is a no, but without learning the concept of oxidation number, it is very, very, very difficult for me to teach you the concept of redox reactions. Now, for your exam, what will come? There are 2 methods. Okay, I'll name both the methods. Method 1, it is called as oxidation number balancing. Okay, so this chapter called as redox reaction in chemistry has only 2 methods. One is called as oxidation number balancing. There's one more method. Okay, apart from this, no other method. Both the methods are some sort of balancing itself. Okay, I tell you the name, don't get confused. It's called as ion electron method. Ion electron method. Both of them seem to be almost the same, but there's a slight difference between both of them. I'll teach you both the methods. I'll teach you 2 questions under oxidation number balancing and 1 question in under this. Practice only these, more than enough. Okay, so today's class we'll be totally doing 3, but doing 3 is not a big thing at all. Learning the rules is the most important thing. Okay, again I'm going to repeat this chapter. What kind of theory might be asked? I tell you right now. Max to max, 1 MCQ can be asked. How? Find the oxidation number of this. You know how to find. Okay, or they'll ask a 5 marker or a 3 marker, not a 5 marker, sorry, 3 marker. Either this or this will be asked. Okay, you cannot predict which one of this, but again I tell you, majority of the times method 1 only is being asked. Majority doesn't mean it's not asked. Both of them have been asked. Majority of the times, number 1 method only has been asked. It's called as oxidation number balancing. Now, obviously, we have to start off with this. Again, one disclaimer is you should not get confused with the rules. Both of them have a lot of similar rules. Please don't get confused with respect to it. Fine. But we will start off with ion electron method. Okay? We'll start off with ion electron method because there are 2 here. No, I'll require more time. This I'll complete off faster. So therefore, I'll start with ion electron method. So heading, you should write it as ion electron method. Please write the heading and wait for me. Okay? I will write the question. I will solve few steps. Whatever happens, you should not copy anything. Wait, because any one of the steps you guys get confused, I'll have to start from the beginning again. So that become a problem. Okay. Now the question goes like this: it is impossible to explain this concept without a question. So I'll start with the question directly. Practice this question itself. Most of the time, this only will be asked. So the question goes like this: Cr2O7 2 minus plus Fe2 plus H plus gives you Cr3 plus Fe3 plus water. Okay, don't get confused looking at this. The reason this is important is because the complete thing involves only charges. That's why this is important. Okay, just like regular balancing is not there. You guys can see that. Fine, you guys can obviously see that. Like regular method is not happening here. Now, what is step number 1? Guys, please don't write. Wait. What is step number 1? Step number 1 is 2 things. Okay, don't get confused. One is officially step number 1. One is unofficial. Officially, I tell you how it works. Officially, you will write step 1 and wait. But before proceeding to step 1, always remember it's an unspoken rule that you're supposed to know the oxidation number of almost all the important things. I'll repeat that. Step 1 officially you write. But an unspoken rule goes like this. What? You're supposed to know the oxidation number of almost everything. Almost everything in the sense, don't get confused. Let's start off with one side. Let's start with your left-hand side. Ignore this then. Talk only about this. On your left-hand side, I can find three things. Okay. 1, 2, as well as 3. This, I can see a valency already. This, I can see a valency already. This also, I can see a valency. But don't you think this is a bigger compound? Bigger compound meaning there are more components. Here, Cr2O7, 2 minus, I do not know the oxidation number of chromium. So, step number 1 is, you're supposed to find the oxidation number of Cr in Cr2O7, 2 minus. Don't you think just now I taught you that? Here, look at this. I will solve and you'll have to show this there also. Okay. You will solve and get the answer as +6, which means in Cr2O7, on top of Cr, +6 charge was sitting there. Getting it? On top of Cr, +6 charge was sitting there. Completely done on one side. This side, okay. Look at on top of Cr, 3 plus is there. On top of Fe, 3 plus. H2O is there. We can ignore this at this point of time. I'll tell you why. Because usually H plus and H2O are like partners. Remember this, I'm using the word partners. These H plus, okay, H plus, H2O and OH minus. Remember these three things are always partners. Okay. They only help the other two things. They only help the main, I don't know what word to use. Let's say the main characters of the story. So in this case, left hand side, the main characters are part 1, part 2. Right hand side, the main characters are part 1, part 2. Both of them are only helping it. Okay. It's just that importance is not given to them, but they are helping it. Now focus. Just now I told you that in the other case that the main characters of the story are this and this. Focus only on them. Fine. Think for a second, more than thinking, observe for a second. Fe2 plus, on the right hand side, it is becoming Fe3 plus, which means the valency is increasing by 1. Increasing by 1 or 2 is not required. Is it increasing or decreasing? It's increasing. Okay. So I'll put one arrow mark on this. It is increasing. Let's talk about chromium. Again, I am not telling chromium oxide, only chromium. Here, chromium was +6. You might tell, sir, 2 minus. I don't care. I'm only talking about chromium. If you ask me why, look at this here. I can't find a O here. Getting it? So only focus on chromium. Chromium was +6. I'll take off this. That +6 moves to the right hand side. It is becoming +3. So from +6 to +3, it is decreasing. So you will, before writing anything, you will mark all these stuff. The moment you mark all this stuff, writing the other steps is very, very, very simple. Okay, it's very, very, very simple. I'll repeat this. First mark what is increasing, what is decreasing. Now, step 1, you should write this. Okay, 2 half cells. This I am writing, guys. In your exam, you should not write, but in your notebook, you guys will copy this. Okay, I am just trying to tell you what is the meaning of step 1. I forgot one word. Separate. Step number 1 is officially separate 2 half cells. Again, if you see, I saw my phone only and wrote this because this is not important for the exam. It's important for you guys. Now, what does 2 half cell mean? Very simple. I'll go back to page number 1 here. The word redox reaction meaning in one specific setup, 2 reactions are happening. 2 kinds of reactions are happening. One is reduction, one more is oxidation. Okay, so which means in one complete setup, one half is reduction half, another half is oxidation half. That's the reason it's called as half cell. Okay, in one apparatus, one half is oxidation, one half is reduction. That's why it's called as half. Remember this. So what does the first rule in English mean? Separate 2 half cells meaning separate the oxidation half and also separate the reduction half. So what I'm going to do, I'll write oxy here, I'll write reduction here. Okay. Now, first of all, how do you find out which one is the oxidation half and which one is the reduction half? These arrow marks will help you. Again, I'll repeat the rule right now. Focus. If the oxidation number, can you see the valency, the top of it? If the oxidation number is increasing, okay, 2 plus is becoming 3 plus. Now, if you what not to do, you should not compare Fe2 plus with Cr3 plus. Why? They are not same. Fe should be compared only with Fe. So Fe2 plus compare with Fe3 plus. It is increasing. If the oxidation number is increasing, then it is always the oxidation half. I'll repeat that. If the oxidation number is increasing, it is always the oxidation half. So what will I write here? I'll write Fe2 plus is becoming Fe3 plus. Getting it? See, I separated that. From the complete question, I only took off the oxidation half. Now, reduction half. Here, Cr plus 6 is there. But the problem here is that Cr plus 6 is becoming Cr plus 3. It is in a combined form. I can't separate it. I found the answer separately correct. I can't manually separate it. So write them together. So you will write Cr2O72 minus with a plus 6 out of it is becoming Cr3 plus. This is step number 1 of ion electron method. You will separate the two half cells, but you will write this only after doing so much of work there. Okay. Now, if you ask me, sir, what about H plus and H2O? That's why I told you beginning only. No, those are like helpers, our partners. They'll only help the main characters in the story. They will not take part in the reaction. Okay. So this is step number 1. Any doubt here at this point of time in separating the two half cells? It is your duty to again. The meaning of half cells also I told you. In one setup, there'll be reduction half and oxidation half. It is your duty to separate both of them. Now, why are we trying to separate? It is in simple language to make it simpler for us in the next step. Okay. Now, should you write this in your exam? Not required. It's only for you guys. Fine. Next, step number 2. I'll go to the next page. Okay, I'll come back later, but for you guys to copy. But we just wait. No doubt here. No. Step number 2. The name goes like this. Step 2. You're supposed to balance the atoms. Again, don't write this. It's only for your purpose of learning right now. Step 2 is balancing the atoms. Now, what does balancing the atoms mean? Focus here. How to do it? Let's go step by step. In the oxidation half, Fe2 plus was becoming Fe3 plus. Now, focus. My question is, it says balance atoms. Careful. Atoms meaning how many number of, 1 minute. How many number of Fe is there? 1 in number. Okay. Right hand side also. How many number of Fe is there? 1 in number. Already balanced. So you will tell a statement to yourself. Oxidation half is already balanced. So, but let's go to reduction half. Careful, guys. Cr2O7 minus Cr2O72 minus is giving Cr3 plus. Guys, careful now, focus. Okay. I wanted it in the plus 6 here because it makes sense. The step number 2 says balance the atoms. Ask yourself a question. On your left hand side, how many chromiums are there? I can see 2. Okay. On your right hand side, how many are there? Just 1. Which means to balance it, I should put the number 2 on your right hand side. I will do this. Getting it? Now, obviously, cross check again. 1 Fe was there, 1 Fe was there, 2 chromiums are there, 2 chromiums are there. Atoms are balanced now. Okay? Atoms are balanced now. Now focus. I'll tell you one small trick here to before going to step 3. Very important. Understand one small thing here. When we're trying to solve step number 2, no, careful here. Focus. Here there was nothing extra. I'll tell you what I mean by extra. In this half, in the reduction half, I can see that left hand side there are 2 chromiums. Right hand side also there are 2 chromiums. But on the left hand side, there are 7 oxygens. On the right hand side, there are no oxygens at all. Now, think. This is where I need some help. I told you who are considered as helpers or partners, H plus, OH minus, and water. There's a rule right now. To compensate oxygens, add water. Okay? To compensate oxygen, always add water. Because H2O has O in it, that's why. Now, my left hand side has 7 oxygens already. My right hand side has 0 oxygens, which means I'm supposed to add water on the right hand side. Okay? Getting it? That's the rule. But if you see here, on the right hand side, there is only 1 oxygen. On my left hand side, there are 7 oxygens, which means I should be adding 7 H2O. Got the logic as how it works? So to compensate oxygen, I'm supposed to add what? Water. You have no choice. You're supposed to add water. Fine. You added water. and it became seven oxygens here. But the moment you added water, automatically H became more. H became more. Totally, how many H is more on the right hand side? 7 times 2, 14 is more. So to compensate this, you will go back to the other side and add 14 H plus ions. Getting it as how it works? 1 second, wait. I'll write it on top. It will make more sense. This step is confusing, I realize. I'll repeat that, but you gotta be careful there. Reduction half. I'll repeat the whole thing again. Oxidation half, 1 Fe, 1 Fe. I am trying to balance only the atoms. Okay. Reduction half, Cr2O7 was there. To compensate chromium, I put the number 2 here. But the problem was there were 7 oxygens on the left hand side. There was 0 oxygen on the right hand side, which means I had to bring some oxygens into picture. How? I add water. Always add water on the other side, wherever it was less. You added water, but if you write water, H2O has only 1 oxygen. We wanted 7. So you put 7 H2O. Fine. But the problem was oxygen got compensated. Additional H came off into picture. To compensate this H, I'm supposed to add 7 times 4. 2 is 14. 14 H plus on the other side. Again, now do you realize why I called them as partners? H plus as a partner. H2O is also a partner. Got the logic as how it works? So, any doubt in this step, let me know right now. Doubt? Cool. Fine. Now, what happens here is, once we add everything, we go to step number 3. Step number 3, the heading says, 1 minute, I'll see. Balancing charges. Okay. Step 3. Should I write it here only? Fine. I'll try to write it here only. Step 3 says balancing charges. Now you will get confused again. If you ask me, sir, what's the main difference between charge and atom? Atom meaning number which is before the letters. Charge meaning the number which is on top of the letters. Getting it? Now we balance the number next to it. Now let's balance the number on top of it. Again, you will go step by step. Let's start off with the oxidation half. Now, 1 second guys, I'll have to cut the call. Yeah. Peaceful. Now I'm trying to balance charge. Now focus. Careful. Left hand side. Guys, think for a second. Okay. Left hand side, I am using the word total charge. Okay. There was 1 Fe and the charge was 2 plus. 2 into 1, 2. Okay. Here, there is 3. Fine. Left hand side, there was 2 plus. Right hand side, there was 3 plus. Understand? To balance atoms, the partners were water, H plus, all these came for help. Okay. When you're trying to balance charges, always remember, you will only use electrons. Only electrons. To balance charges, only electrons. To balance atoms, you use H plus, OH minus, or water. Okay? That's how it works. Fine. Now focus. Left hand side, you had 2 plus. Right hand side, you have 3 plus. Okay? I'm supposed to balance them. This is less positive. This is more positive. Now think for a second. The hint says I'm supposed to balance the charges only by adding electrons. Wherever an electron goes, it carries a negative charge with respect to it. I hope you guys know this. Because electron is always 1 minus. So you tell me, there is 2 here, there is plus 3 here. Where should I add a negative charge so that they get balanced? Obviously, where the bigger number is there. Okay, so how many more should I add? Now, what is the difference here? 3 minus 2 is 1. Okay, so what I'm going to do, I'll have to add 1 electron. I'll have to add 1 electron this side. I hope you guys understood that. Now, focus. Total charge on the left hand side is 2. Total charge on the right hand side, 3 minus 1. Why? Even though I wrote plus 1 electron only, electron meaning it's a negative charge. Okay, it's like plus 3 minus 1. Here it is 2 plus. Do the math, they'll match. Okay, so I'll repeat it. The helper when trying to balance charge is always electron. Remember this. Again, I use the word total charge. Same concept that let's apply here. Same concept that let's apply here. in the reduction half. What is the total charge in the reduction half? Careful, guys. Left hand side, there are two parts. Careful, two parts. The first part has 14H plus, which means plus 14. Okay, and minus 2. So the total charge on the left hand side is plus 12. How? Math. Plus 12, plus 14, and minus 2. I think I'll rewrite that way the next time. It'll be useful for you. I'll just copy this. 1 minute. Reduction half. I'm trying to balance charges. Who is the helper? Electrons. So 14H plus Cr2O7 2 minus gives you 2Cr3 plus 7H2O. This was there. I'm finding what total charge? Here, this side. 14 plus 14 minus 2. So the answer is plus 12. Okay, here, careful. 2 into 3. Okay, 2 into 3 plus 6. Okay, water has no charge, meaning 0. So on the left hand side, there was plus 12. On the right hand side, there was 6. First step, what is the difference of charges? 6, which means I'm supposed to add 6 electrons. Which side? The more dominant side. Who is more dominant here? Left side. Okay. Why 6? What's the difference? Okay. Who is the helper in while balancing charges? It is always the electrons. So you will add 6 electrons on the more dominant side. See here also. 3 minus 2 was 1. I added 1 electron on the more dominant side because I should suppress it. To suppress it, I'm supposed to choose a dominant side first. The dominant side is always the side which has more amount of total charge. So here it was the left side. So what I'm going to do to compensate that, I'm going to add 6 electrons. Plus 12 was the total charge here. Plus 6. To compensate that, I added 6 electrons. That's all. Now check. This was okay. Now plus 12 was there already. 6 electrons meaning minus 6. Both of them are balanced. Got the logic as to how it works? That's exactly how things will work. Now the charges are also balanced. Okay. I'll copy this here. 1 minute. Oxidation half. On top I'll copy. Fe2 plus gives you Fe3 plus 1 electron. Step number 3 is done. Now step number 4 is very simple. Step number 4 is balance the electrons. Okay, balance the electrons. Now focus. Look at this. Look at both of them. Okay. In the second equation, there is 6 electrons. But in the first equation, there is only 1 electron. Step number 4 says, I'm supposed to balance the electrons. So, what number should I multiply where? Very simple. To the first equation, if I multiply by 6, again if you see, I multiplied the whole equation with the number 6. Okay, why? Because I looked at it, 6 electron I could see here, I can only see 1, they are not balanced. So to balance it, I am multiplying it by 6. After multiplying, be careful, oxidation half, after multiplying, again, we should multiply the 6 throughout. Fine. So it becomes 6 Fe2 plus on the left hand side gives us 6 Fe3 plus 6 times 1, 6 electrons. Okay. Now if you ask me, sir, why didn't you multiply anything with respect to the reduction half? I multiplied. It's just that I multiplied with 1. Okay, because 6 into 1 gives me 6. Whatever is there, copy paste for the reduction half. Reduction half. 6 electrons plus 14H plus Cr2O7 2 minus gives us 2Cr3 plus 7H2O. Last step we are in now. After doing everything, I'm supposed to add them. I'll tell you what's the meaning of add. Add both the sides. Okay, I'll tell you what's the meaning of add both the sides. Left hand side, okay. Add meaning I'm supposed to, this is the only place, step number 5, where I combine the things. I combine both the halves. Okay. I'm actually thinking, let's not do the other method today. because this only is so much, but if I teach other method, you'll get confusion. So next class will do the other method. But this method I'll explain this again, and it's better because again first time no, it'll go overhead only, and they're very similar rules also. That's fine. Fine. So we'll add meaning. Guys, careful. Oxidation half. What is there on the left hand side? 6 Fe2 plus. Only copy that. Put a plus. Come back to the reduction half. In the reduction half, whatever is there, copy paste that on the only the left hand side. I can find 6 electrons, 14H plus Cr2O72 minus. Everything I'll copy. Plus 6 electrons plus 14H plus Cr2O72 minus. Done. I'll put the arrow mark. Whatever is there on the right hand side, on both the places, copy that. Here, I can find 6 Fe3 plus 6 electrons. Copy that. 6 Fe3 plus 6 electrons. And this 2 Cr3 plus 7H2O. Once again. Plus 2 Cr3 plus 7H2O. This is supposed to be my answer, but focus. Cancel off if you can find something common on both the sides. I can find something common. Okay, whatever is remaining, that's your answer. That's all. It's balanced. You can check it's balanced. Okay, so it's supposed to follow 5 steps. I know it is going to be kind of it's kind of hectic. Can't help. The more procedures you follow, the better you guys will get. Okay, no skipping steps here. Remember this. Fine. So basically, we start off from step number 1. Yeah, it's called as the oxidation number method. Focus. So first, we find the oxidation number for whatever is required. I send the recording on the group anyways, but I'm just trying to explain it again. 6 here, you'll find the oxidation number. Next, for whatever is required, then you'll check where the oxidation number is increasing, where the oxidation number is decreasing. That's your job. Okay. Then you will separate them. Why are these arrow marks important? Because if the oxidation number is increasing, then it means oxidation half. If the oxidation number is decreasing, then it means reduction half. You gotta keep this in mind. Now, oxidation half, reduction half, you separate them. It's important for you to separate. Fine. So once you separate them, it became Fe2 plus is giving Fe3 plus. You guys copied that. Reduction half also, you copied it. So first step is only separating and copying it. Now, you have 2 things. You made 1 as 2 basically. You separated them. You go to the next one. Step number 2 says supposed to balance only the atoms. What does the meaning of atoms mean? That the number before the compound, before the elements. Okay, before the elements, whatever number is there, try to get that balanced. Oxidation half, 1 was there, completely fine. But when it comes to this part, to this half, 2 chromiums were there. To compensate 2 chromiums, I put 2 there already. Okay. Now, but the problem was there were 7 O's and there was no oxygen on the right hand side. That is when I'm trying to balance atoms, who are my friends? Water and H plus are my friends. Okay. So to balance oxygen, I'll add water, whichever side required. This already had oxygen. This did not have oxygen. You add water. But the problem here was, if you add H2O, it was only 1. But the left hand side had 7. So you put 7 there. Okay. Now, additional one more problem came. So oxygen got balanced, but the hydrogen was not balanced. What is 7 times 2? 14. 14 what? H. So 14H plus was deficient that side. So was not being balanced. So you'll put 14H plus the other side. Getting it? So this place is the place where you're supposed to take help of your partners and then get the job done. Okay. Now again cross check. Is everything balanced with respect to atoms? Yes. Once the atoms are balanced, you will start balancing charges. But remember, when you're trying to balance charges, who is your friend? Only one friend. Electron is your friend. And wherever electron goes, it carries a what charge? Negative charge. Now, how to balance charges? Always remember, it should always be with respect to total charge. Okay, always total charge. Now, on the left hand side, Fe2 plus was there. On the right hand side, Fe3 plus was there. The total charge there was plus 2. The total charge here was plus 3. First, what I had to tell you? Find the difference. 3 minus 2 is 1. Add that 1 electron on the more dominant side. Who's more dominant between 3 and 2? 3. More in number, no. So add one electron here. Getting it? Done. Similarly, go to reduction half. Yeah, it's here, see. Like this reduction half. Reduction half. So this was already there. This was already there. Fine. If you see whatever I underlined, that was the total charge. Total charge was 14 plus. You're supposed to take the number and then multiply. I hope you guys realize as to why we balance the atoms first before the charges, because I'm multiplying the numbers along with the charges. No, that's why I want the number first. Once you find the exact number, then multiply with the charges. It will become more simpler. It will give you a much more accurate answer. Okay. So 14 plus, 14 pluses and 2 minus, which means the total charge was plus 12 here. The total charge was plus 12 there. Here, 2 times 3, it gives you 6. Water has no charge, so 0. It was plus 6 here. Okay. Again, not being balanced. One is plus 12, one is plus 6. What did I tell you? Find the difference first. What's the difference? 12 minus 6 is 6. You will add 6 electrons. Which side? The more dominant side. Dominant is plus 12. Therefore, I added 6 electrons on that side. That's all. Once you add electrons, step number 4 is balance the electrons. Very simple. Oxidation half here. Oxidation half here, add 1 electron. Reduction half here, add 6 electrons. So to balance that, I'm supposed to multiply with 6. Getting it? So I multiply by 6. Why am I not multiplying the reduction half? Because it's already balanced. That's why. 6 times 1 gives you 6. 6 is already there. After multiplying, again, careful. You're multiplying 6 throughout the equation and not only part of it. Throughout. So it will become 6Fe2 plus 6Fe, everything 6. Fine. Once you're done with multiplication, next, add all the sides. Add all the sides in the sense, add all the left-hand sides, add all the right-hand sides, write them together. Once you write them together, check if something can get cancelled. Electron gets cancelled. Whatever is remaining is the answer. That's the end of it. Okay? So, this question only will be asked. Just copy this fast. Write along with the steps. Done. Go to the next slide. Write the names. It's for you. It's for your sake, not in the exam. Next slide. Next slide. Okay, just copy this off and you guys can leave. The next method I'll teach you in the next class. I'll send the recording. Please watch this again. Very important for your exam. For sure, this will come 5 marker or 3 marker. This is actually a 5 marker, correct? Yeah. So don't ignore this. Learn the first method properly, because if you don't learn this, then the second method becomes a problem. You'll get confused with respect to the steps there. That's why.
That's it. Cool. See you guys.